Hi, welcome back to Tutor Think. My name is Daniel, and in this video I'll be taking you through application of calculus, a simple question under application of calculus. It is actually a special type of question that was requested by some students. Alright, so I have a topic under Reynolds number. It says that an important characteristic of blood flow is the Reynolds number. As the Reynolds number increases, blood flows less smoothly. For blood flowing through certain arteries, the Reynolds number is R equals 10R into 2 minus ln R, where R is the radius of the artery. The first question is, find the radius R of the arteries that maximizes the Reynolds number. And the next is determine the Reynolds number when it is maximum. Alright, so this is what we have. Let's see how we can handle it using calculus. So first we would have to put down our equation. We have RR equals 10R 2 minus ln R. So the next thing we have to do now is to understand the question. The question says we should find the radius of the artery that maximizes the Reynolds number. That means we are trying to locate R by making R the subject. That is small r. So to make small r the subject, in application of calculus, we need to apply product rule. We need to treat the two functions as product functions. So what do I mean by product functions? This means that I will treat 10R into bracket 2 minus ln R as two separate functions, where 10R here is the first function and then 2 minus ln R is the next function. When that happens, now we have two products that are multiplying, two separate functions multiplying themselves. And then we can apply what we call the product rule in differentiation to complete this task. Now this will help us to be able to make R the subject. Then we can find the value of R from there. So first, let me explain the product function to you, the product rule in differentiation. So let's assume that I have a function y equals uv. Now u here is the first function and v here is the second function. Or let me use f of x and g of x, because I'll be applying f of x and g of x here. So let's assume that I have y equals f of x multiplying g of x. Now f of x here is the first function and g of x here is the second function. Now when I take the derivative of y equal to this, then I'm having a product rule. I'm supposed to apply product rule here. The first I'll do is to either maintain the first function, differentiate the second function, plus maintain the second function and differentiate the first function. Now it's still the same as me taking the second function and then differentiating the first function. So let's assume that differential of this function or differential of y will give us y bar, so that it will be simple for me. Now from product rule, y bar will give me the maintain the first or the second function. Let's select the first function. So I'll take the first function, then I'll multiply the result by differentiating the second function. So differential of the second function will give me g bar of what? X, plus, now pick up your second function, which is g of x, and multiply by the differential of the first function. So f1 of what? X, or f bar of x. Now this means that I have applied product rule. So product rule says that derivative of y equals maintain the first function, differentiate the second function, plus maintain the second function, differentiate the first function. You multiply. So now when I substitute the result of these functions inside the formula here, I can generate my final answer. So let's assume that y was equal to, let's say, x squared sine x. So this is x squared, this is sine x. Now this one is f of x and this one is rg of x. So when I differentiate the two functions, x squared, the result is f1 of x equals 2x And when I differentiate this one, I have g bar of x. This bar here means first derivative or first differentiation. So I will get something like, this will give me cos x. The differential of sine x is cos x. So now when I substitute 1, 2, 3, 4 into this formula, I can generate my final solution. So the derivative of y here will give me f of x, which is x squared, times j bar of s, the first derivative of this, times this one, plus g of x, which is sine x, multiplying 2x, which is standing for what? F bar of x. Now, when you are able to simplify this by substituting this result here, you are done with what we call product rule. So I guess you got the concept of what I was saying. I didn't really substitute that because there's no need. I will bring you back to the question and then apply this same rule here. So let's start. Now the first thing I'll do is to name the two separate functions, this one f of x, this one g of x. So let's say something like let f of x be equal to 10r. Then let g of x be equal to 2 minus ln r. Alright, so now differentiate the two separate functions separately. So the first thing I'll do is to differentiate f of x. So differential of f of x, we have f bar of x will give me what? Now when I differentiate 10r, the result is 10. Why? Now assume that the power that we have here is 1. So we use the power rule. 1 times 10 will give us 10. Then you subtract or reduce the power by 1. So this is giving us 1 times 10, 1 minus 1 at the exponent. So the exponent there becomes 0. Anything raised to the power 0 is 1. So the variable here to power 0 becomes 1. So r is 1. 1 times 10 will give us what? 10. Now let's differentiate the second function, which is g of x. So we have j bar of x will give us minus 1 over r. Now why am I saying that? The differential of a constant here is always 0. Put that in mind. Most of you are aware of this. And then the differential of ln r is 1 over r. So whatever variable you have here, when you differentiate it, is 1 over that variable. So if this side was supposed to be ln x, then the result is what? 1 over what? X. Now we have a negative here, so that was why I brought the negative here. So now we have the two differential equations, f bar of x equals 10, j bar of x equals 1 over what? R, the negative of that. Now we need to use product rule, substitute this result into the product rule formula. Now what you need to know is that we were actually differentiating the main function here. So we will quote the formula and substitute the result. So now the differential of r is this, and it will be equal to, take the first function, which is f of x, multiply by the derivative of the second function, g of x. So we multiply by this one. So I have g bar of x plus, now go back and take the second function, g of x, multiply by, the dot here means multiplication. So multiply by the first derivative, which is f bar of x. So now I'm done. Remember that multiplication here is commutative, so I can choose to maintain the second function first and multiply the result by this one here, and then I can choose to turn this one to, and I'll get the same result. So now what do? Let's substitute what we have here into this formula. So we have r bar of r will give us, now what was f of x? F of x was 10r times, what was g bar of x? G bar of x is negative 1 over r plus, now we move on to g of x. G of x here is 2 minus ln r. Now we multiply the result by f bar of x, which gave us 10. Alright, so now we can simplify this. You and I know this r will cancel this one. So we are left with -1 times 10. So we have this time this giving us -10 plus we have this times this, we have 20, and then 10 times this is giving us -10 ln r equals to this. Now the next thing is we can simplify this and this, which are the same. So we have r bar of r equals this, and this will give us 10 minus 10 ln r. So now we have the Reynolds number here equals 10 minus what? 10 ln r. Now let's go back to the question. The question said we should find r of the artery that maximizes the Reynolds number. So at maximum, the derivative of the Reynolds number should be equal to 0. So at maximum, r bar r should be equal to what? 0, so that we can make r here the subject. So let's do that. So at maximum, the derivative should be equal to 0, which is r bar r should be equal to 0. So we have 0 equals 10 minus 10 ln r. So now I can move this one to this side, giving me 10 ln r equals 10. Then I can divide through by 10, giving me 10 ln r over 10, 10 over what? 10. This will take care of this. Then I have 1. So I'm getting ln r equals 1. Now to be able to make r the subject, I need to take care of what? The ln. Now to take out the natural log, I need to introduce the exponential function. So this becomes e to the power ln r equal to the same thing here, e to the power 1. So that the natural log will cancel the exponential function, and I'm left with what? R. So here I have r equals e raised to the power 1. Now this is very simple. Now I can find the value of r, which is the radius of the arteries. Now let's use the calculator. Now we have the exponential function here. So all I need to do is to press shift and activate it. So shift and this, and to the power 1. The result is 2.718. So now we have r equals 2.718. No unit. Now let's go back. The next question says that determine the Reynolds number when it is maximum. So we are determining the Reynolds number when it is maximum. We have already found at maximum r bar r equals 0. We are done with finding the value of the radius r. That was the first one, which is 2.718. So all we need to do now is substitute r into the original function to find the Reynolds number rr. That is what he says, the Reynolds number when it is maximum. So at maximum, r equal to this, and at maximum, what will be the Reynolds number? So the Reynolds number here will be 10 into r, 2 minus what? Ln r. So you just substitute the values here, and you are done. So let's go to solution II. So we know that rr equals 10 r2 minus ln r. So I know the value of r. You can choose to substitute r here too. rr is giving us 10 multiplying 2.718 times 2 minus ln 2.718. Alright, so let's simplify this. This is giving us 10 into bracket 2.718 bracket close multiplying 2 minus Now we have the lane function here. So you just press on that. Lane 2.718. Okay, so I have to double close the bracket. Alright, so now let's press equal to. So the Reynolds number here is given at 27.183. When I run this side to 3 decimal places, so we are having 27.183. So we have RR giving us 27.183, and this is our final result. So the Reynolds number at R equal 2.718 is giving us 27.183. So at maximum, the Reynolds number is this value. So this is the end of this solution. I guess you got the concept. All we need to do is to apply product rule in differentiation for this type of question. Alright, so my name is Daniel. Please subscribe to this channel and I will see you in the next one.